just a final reminder. You are taking your final exam tomorrow morning at 7:40. I'm just checking, okay? Any virtual who are watching this right now, you are also taking this if your first hour, taking this at 7:40 tomorrow morning. If you have any work that you need to finish or correct, you have to get that turned in, preferably by the time you take your final. If not, I will not accept it after 2:55 p.m. tomorrow. Okay, so end of the school day for me is the cutoff because I plan to have all of your finals graded and in Power School by the time you get to school on Friday. So your grade for this class will be finalized.
You're just busting them all out.
Your grade for this class will also be the grade that you get on the transcript for IU. Okay, because I've been told to run it exactly the same. Percentages are the same. Breakdowns are the same. Okay? Any questions about any of that? No. Just a reminder, this semester was one dual credit class. Next semester is a different dual credit class. Huh? Okay. So just a reminder, this is the end of this dual credit class. Okay, I cannot tell you that enough. You can also use your review on your final exam. So if you're virtual, I expect that you're going to upload a picture of your review before you take the final. And then you'll take it just like normal. You will get on the Google Meet, have to have your camera on for the entire class. And then I will give you the access code for it. In class, you'll have paper copy just like normal. Any questions about any of that? Any questions we do not get through today from the review, I will post a video for it at some point tonight. So you can review with that. I know, right? Okay. So let's go ahead and pick up kind of where we left off. To be honest, I don't remember where we left off.
Pretty sure we left off at like 20.
It was not 20.
It was definitely. Oh, I think we should start.
I think it was 9, the last one.
9 was the last one we did. Okay. So on page 10, or not page 10, the page that has number 10 at the top, you can cross off 11B. I will not give you one like that on your final exam. So I'm not going to make you really fret over it.
It's terrible, that's why.
A lot of people don't like piecewise functions. It's okay.
I don't
Audio
even
center
remember that.
bus hasn't shown up yet.
So let's go ahead and do 10, number 10. A couple of my answers on the review were wrong. I have corrected them as I went, and I will post a new picture as soon as I possibly can. Just know that some of them are a little bit wrong, and for your review, I'm not grading on what's right and what's wrong. I'm just grading that you did it.
Can I cross off 27B then? You said you were gonna give it.
Yeah, I crossed off a couple of them on the answer key, so
Yeah.
clearly I'm not going to be using those if I crossed them off.
Can you tell us?
25B is another one you don't have to do. 27B, I will not give you one like, but it's not a bad thing to kind of think about that problem. And then 31C, I also will not give you one like.
Let's go.
But they are crossed off on the review answer key as well.
Can you
I saw that going through it last week.
I don't even know what it is.
It's the unit of.
Okay, so let's look at number 10. Number 10 asks us to find the center and the radius of the circle given this equation. So 4x squared plus 4y squared plus 24x minus 16y plus 41 equals 0. If I'm given a circle equation like this and I need to find the center and the radius, I need to get it into factored form. The only way to do that with two variables like this is to complete the square. So thinking back to that lesson, what's the first thing that I need to do for this problem? Not yet.
No, subtract 41.
Move my constant to the other side. So I'm going to subtract that 41 over. So I get 4x squared plus 4y squared plus 24x minus 16y equals negative 41. Nicole, what do I do next? I divide out a common factor, okay? Because I don't want anything in front of my x squared or my y squared. So I divide everything by 4. And when I get it, or when I do, I get x squared plus y squared plus 6x minus 4y equals negative 41 over 4. Because then where does it go?
Right.
Well, I'm gonna have two parentheses, so does it go on the front of each parentheses, or does it go in front of all of it and get multiplied in afterwards? What's happening?
Oh.
Right, that's a thought. So we just do it this way, it makes it a little bit easier to work with, less chance of a mistake happening. What do I need to do now if I know end goal is to complete the square?
Arrange.
How am I gonna rearrange and why?
You could, like, you just move the x's together and the y's together.
Right, because when I complete the square, I'm completing the square with an x squared and an x and a y squared and a y. So I rearrange, getting my like variables together. So I have x squared plus 6x. I'm going to put that in parentheses, plus y squared minus 4y in parentheses equals negative 41 over 4. I left some room in these parentheses because I'm going to be completing the square. How do I complete the square? What do I do with the 6x? I divide the 6 by 2 and square my answer. So 6 divided by 2 is 3, and 3 squared is? So I add 9 here. I also have to add 9 over here. I have to keep this in balance, so anything I add onto the left side, I also have to add on to the right side. I do the same thing with the y's. What's half of negative 2 or negative 4? Negative 2. What's negative 2 squared?
4.
So I add a 4 and I add a 4. By completing the square on the left-hand side, I have ensured that each of these are a perfect square trinomial, which means it's going to factor into the same factor twice. So what number times itself equals 9 and plus itself equals 6? 3. So this factors into x plus 3 times x plus 3, which I rewrite as x plus 3 squared. Plus, I do the same thing with the y's. What number times itself equals 4, but plus itself equals negative 4? Negative 2. So this one is y minus 2 times y minus 2, which I write as y minus 2 squared. And then equals, what am I going to do with that? Not a decimal. Say it, Nicole. Right, I need a common denominator of 4 so I can put all of these together. 9 times 4 is 36, so that becomes 36 over 4. 4 times 4 is 16, so that becomes 16 over 4. And then I just add them together. 36 and 6 is 52. Minus 41 is 11. And then over 4, because that was my common denominator. So now I have my circle equation. Can I pull out the necessary information? Yeah, what's the center of the circle? Well, I look at the number attached to my x, and I take its opposite sign. So that's going to be a negative 3. Then I take the number attached to my y with the opposite sign, so positive 2. And then my radius is 11 over 4, correct?
Yeah,
No, you have to.
In our center equation, or not my center, my circle equation, it's always said equal to r squared. So to find r, I'm going to need to square root that answer that I got. So when I square root it, I get plus and minus 11 over 4, or the square root of 11 over 4. Does this mean I'm going to get 2 radius answers?
Yes.
Can I use 2 radius answers?
Yes.
You can't have a negative.
I can't have a negative radius. It's a length.
You could.
So I'm only using the positive version of this. Make sure we're thinking about it in the context of the problem. Can I reduce the square root of 11 over 4 at all? How?
No.
I can.
Square root of 11 over 2.
The square root of 4 is 2, so this is the same as the square root of 11 over 2, where the 2 is not under the radical anymore. And then that is my radius. Make sure it's very clear to me what is or is not underneath a square root sign, because I will count off if I can't tell.
Dang it.
Okay, questions, concerns, or issues on that one? 11A, I do not have one that is nearly that difficult on there. So this one, I'm going to suggest if you get one like this, you graph it on your graphing calculator, and then that will help you identify your domain, your range, and your increasing and decreasing. So that's how we're gonna work through this one.
Let's go.
We're gonna pretend like we graphed it because that's gonna be the fastest way for you. So if I'm graphing it in my calculator, I went to the Y1 spot and I put it in exactly how it looks. And then I'm going to adjust my window so I can see what's happening.
Let's see the graph.
I'm gonna move it in a second.
You plug it in, you said exactly, right?
Yeah, exactly as is. So when I plug it in, I get a graph that looks a little bit like that. That should be what you get.
Did you do anything for Y2 or no?
No, I just have one line
You just take
or
graph.
one function. Yep, just hit graph and you'll adjust your window. You can practice that on your own time though. I do want to make sure we can get through this problem. So once you graphed it, you should get something that looks like this. Is anybody not getting a graph that has this on it?
I hit graph and then it pulled up like errors and text.
That means you put something in wrong. Did you use the minus or did you use the negative?
Well, I did that at first, but then I had.
Use the wrong X.
I put,
Do that.
I did, I put that one in the
But I have
square.
no idea. But that's okay. Okay, cool. Okay, so we get a graph that looks like this, correct? For this problem, I wanted to find a couple of things. The first one is I wanted to identify my domain. Then I wanted to identify my range. And then I wanted the intervals where it was increasing and decreasing. So I always like to start with domain and range first. When we talk about domain, I talk about the possible X values that I can plug in. So on my graph, that means I'm looking to see what X values give Y values here. Yes.
Okay,
Oh, answer, go for it.
negative square root of 10.
Is this value right here? Good. So that's my leftmost point. What's my rightmost X value? Positive square root of 10. I know this because if I plugged either of those into that equation, I'm going to get 10 minus 10 under my square root, and the square root of 0 is just 0. That's how I know that that's how it worked. So then my domain goes from negative square root of 10 to positive square root of 10. You can write it using inequalities, or we could write it as an interval. Either one of those are acceptable answers. We always look left to right when we're talking about domain. After identifying the domain, I move on to my range. Range are my possible Y values. So bottom to top, I need to identify my bottommost point and my topmost point. So what's the bottommost Y value I get? You can find it on your calculator by moving the little cursor, or I could look at the X value where my bottommost point occurs, because I can see pretty clearly it's right here. And I can plug it into my function and find out what it is. What X value is that happening at?
Okay, what are you talking about?
If this is my bottommost point, what X value is that at?
Okay.
0. So I plug 0 into this, and what do I get? Negative square root of 10. So that has to be my bottommost y value. I see that it's the bottom point, right? I see it's occurring at x equals 0, so I plug 0 in for x. 10 minus 0 is 10. Square root of 10 is square root of 10. Negative on the front makes it negative square root of 10. You also could have just gone on your calculator. Okay, then I'll look at it in a second. Hold on. So we did the bottommost value. What's my topmost y value? 0. Both of those are included, so they need to have a hard bracket. You also could have gone ahead and done the inequality. Instead of an x in the middle, though, we'd have a y, because range are our possible y values. So then I have the increasing and the decreasing. So when I'm talking about increasing, that means as I move left to right on my graph, my y values go up. If I'm talking about decreasing, when I move left to right, my y values go down. Is this entire graph increasing? Is the entire graph decreasing? So I'm going to have one of each, right? So I like to move from left to right. So starting at the leftmost part of my graph, is it decreasing or increasing as I move right? Decreasing to begin with until I get to this point right here. So that means from negative root 10 to 0, it's decreasing because that's where it started to change. For those, I use the soft brackets because technically at those points, it could be changing or it could be stagnant. Then once I hit 0, I evened out. And as I moved right from 0, what happened on my graph? It went up, right? So that would be increasing. So from 0 to root 10, it is increasing. And that's all I need from this problem. Again, 11b, I will not give you a piecewise function. It's not worth the time. So then 12 is composition of functions. Do we need to go over that one? Does anybody really, really not get it?
Which question?
Number 12. Okay, it's just plugging one function into the other function. We always do inside into outside. So then we have 13, which is a super duper lovely story problem. So it says, suppose the cost of driving an automobile is a linear function of the number X miles driven and that gasoline costs $3 a gallon. A certain automobile presently gets 20 miles per gallon, and a tune-up that will improve gasoline mileage by 10% costs $120. So this is a three-parter. Part A asks me to express the cost, C1, of driving without a tune-up. Okay? So this means if I did not get the tune-up, how many miles per gallon is this car getting?
20.
20. It says it right in the problem. Right? So I'm getting 20 miles per gallon. How much am I paying per gallon? $3. And then I'm driving X number of miles, right? Because that's the variable that's going to change. To find the total cost, I need to take this $3 per gallon and multiply it by the number of gallons that I'm going to need. So how does that relate to the number of miles? So say I drove, 500 miles. How do I figure out how many gallons of gas I used? So I would do 500 divided by 20, which means if I'm driving X number of miles, I'm going to do X divided by 20 and then multiply the answer by 3. Because for every gallon of gas, I have to pay $3. Of course, I would write that a little bit nicer. So I'd have 3 times X over 20, or you could always write it as 3 over 20 times X, or 3X over 20. All of those are equivalent. I don't care which one you use. So whichever one makes the most sense to you. Do we understand how I got that equation for that first vehicle? If anybody confused, please tell me if you are. Okay, so for part B, I would like to find the cost of driving with a tune-up in terms of X number of miles. So kind of the same as number 1, except we are assuming that this car got the tune-up. So the first thing I need to account for is how much that tune-up cost. How much was it? 120 bucks. How much is this car paying per mile? Not per mile, per gallon. Just like the first problem, still $3 a gallon. How many miles can this car drive on 1 gallon if it gets the tune-up?
22.
Okay, so this is a little bit different part. It says if I got the tune-up, I could drive 10%, or it would increase my mileage by 10%. So I take 10% of 20, which is 0.1 times 20, which is 2, and I add it to the 20 miles per gallon I was already getting. So 20 plus 2 is 22 miles per gallon. Anybody confused about how we got the 22? So just take 10% of the mileage I was already getting, and then add that number to the miles per gallon, and it gives me my new mileage. We're all good there. Okay, so then I set up my equation, very similar to how I did before. So I'm going to have X number of miles divided by 22 miles per gallon times $3 per gallon of gas I have to buy, plus the amount I paid for the tune-up that gave me the better gas mileage. Again, you don't have to have it written exactly like that. This is the same as 3x over 22 plus 120, or you could have had 3 over 22 times x plus 120, or you could have had, there's like 4 different ways you could have written that. All of those are equivalent. Anybody confused by how we got that equation? We're all okay. Which leads into part C. And part C asks me to identify how many miles these automobiles must drive in order for the tune-up to be worthwhile, which means that the cost of driving without the tune-up has to be greater than the cost of driving with the tune-up. That's what I'm looking for. I'm looking for the point where it's costing more for me to drive without it than it is for me to drive with it. So I'm going to set it up exactly like this. I'm going to take the equation C1, and I'm going to set it greater than the equation C2 that we already found in A and B. So what I do, I get 3x over 20 is greater than 3x over 22 plus 120. Everyone okay with how I set that up? And now I get the pleasure of solving this problem, right? What's the first thing I really don't like?
Everything about
The fractions. I actually have 2 of them, and I have 2 different denominators, so I can't even put them together.
Multiply everything by 220.
440, right?
Why 220?
Do they both go into 220?
Yeah.
Yeah, they do. Okay. You could do that, or you could do 440. It doesn't matter. So what I need to do is I need to multiply all of these by some number that both 22 and 20 go into. If you can't come up with one, unlike Gabe, you could just multiply these 2 numbers together and multiply every term by that number. So if you didn't know that they both went into 220, you could do 20 times 22 is 440 and multiply every single term by 440. That'll work too. That's the way I'm going to do it because some of you, or most of you, probably just don't want to take the time to figure out their least common multiple. Okay? So we're going to multiply everything by 440 and see what happens. I know I don't even have my calculator on me.
You go, boss.
No, you need it more than I do. Okay. So I want you to multiply all of those numerators by 440. Do it anyway.
I actually didn't even multiply it. I just
2,648,000,000.
That's not right.
Yeah, no, I
No,
just made that
no,
number
it's
up.
I didn't even
Technically, don't.
multiply
You're
it.
gonna have to multiply it.
I just put them over 220. I left myself.
Okay. So we do 3 times 440, and then divide our answer by the 20 that is in the denominator. And I get 66x is greater than. Then I do 3 times 440 divided by 22, and I get 60x plus, and then I do 120 times 440, and I get 52,800. So the way I'm looking at this right now, I have 66x is greater than 60x plus 52,800. My goal here is to solve for x. So what am I going to do first? Subtract the 60x over to the left-hand side. When I do, I get 6x is greater than 52,800. And then I do what? Okay, it's important to remember that when we have an inequality and we're doing division, we need to be aware that if we divide by a negative, the sign flips. Okay, if we divide by a positive, we're fine. Everything stays the same. But if you divide by a negative, it will flip. Okay? So we divide each side by 6. And I get x is greater than what number?
48.
8,800.
So
Which means that I would have to drive at least 8,800 miles in order for that tune-up to be worth it and actually save me money in the long run.
So is
It's
it
a lot of
worth it?
money. Well, if you drive a lot, then sure.
But let's say you don't have that car.
How long will the tune-up actually work?
That, I'm not aware of any of that information. Okay, so that was all of 13. Are we okay with that?
Yeah.
Anybody have any major issues with that?
Yeah.
Yeah.
Someone does.
Okay. Any questions before we move on? I'm assuming we're going to 14 next.
No.
Yes.
You should definitely.
Do we need to do 14?
I have an answer, but I don't think it's right. But like,
Okay.
You should do 16.
Well, hopefully we'll get to it. We should get to 16.
Because this other stuff's easy. Or, I mean, like. I mean, I'm gonna probably not try my grammar anymore.
Okay, 14, because I heard that we should do it.
Yeah.
14 says to find all values of x such that f of x is greater than 0 and all x such that f of x is less than 0, and then sketch the graph of f. So the function it gives me is 1 over 15 times x to the 5th minus 20x cubed plus 64x. In order to set up this problem, I need to find the zeros of my function. Of course, we could, do the whole possible rational zeros, set up my list, do synthetic division repeatedly until I find them. Or I could try factoring this and making it a little bit easier to work with. So looking at the numbers, I'm not sure there's a whole lot I can do. But looking at the variables, what do I notice? There's an x in all of them. So I can take an x out and I put it out front. And when I do, I get x to the 4th minus 20x squared plus 64. And that to me looks like a quadratic. Because my first exponent is twice what my middle exponent is. Which means that we can do our u substitution if you feel more comfortable doing it that way. And I'm going to say the x squared is equal to u, and I'm going to replace all my x squares with u's. So then this becomes 1 over 15x times u squared minus 20u plus 64. I'm looking for two numbers that multiply together to get positive 64 and add to get a negative 20. Negative 16 and negative 4. So I have 1 over 15x times u squared minus 16. Oh, sorry, not u squared. U minus 16 and u minus 4. Right here is where I would go ahead and replace the u with the x squared that was there originally. So I actually end up with x squared minus 16 and x squared minus 4. And what do I know about each of those factors? They're difference of squares, which means they continue factoring, and they factor beautifully into the same factor twice, but one's addition and one's subtraction. Okay, so then this will factor into 1 over 15x times x plus 4, x minus 4, because 4 times 4 is 16, and I need them to cancel, so it's 1 plus and 1 minus. And then x plus 2, x minus 2, because 2 and 2 is 4, and I need them to cancel, so 1's plus and 1's minus. So once I have it factored as far as I can go, I set each of these equal to 0, and I solve for the x, because that will tell me what all of my zeros are. I will tell you that this is where I see the most mistakes happening. I don't have 4 zeros, I have 5.
What?
I have 1 in each of these factors, and then I had a 1 over 15x at the front. That x still counts as a 0, so I still have to set that equal to 0. So when I do, I get 1 over 15x equals 0, x plus 4 is 0, x minus 4 is 0, x plus 2 is 0, and x minus 2 is 0. I go ahead and I solve each of them for x. When I multiply the 15 over, 0 times 15 is still 0. So my 5 zeros are 0, 4, negative 4, 2, and negative 2. Are we all okay there? Everybody see what happened? Is that real or is that fake?
Perhaps. 47. Perhaps.
So now is the really, really fun, easy part where I get to use a calculator. I'm trying to identify where this function gives me positive y values and where it gives me negative y values, which means I have to test a point between each of these zeros because I'm checking those intervals. So what I do first is I draw a number line, putting all of these on there, going from least to greatest. Then I pick numbers that exist in between each of those and around them, and I plug them into the original function that I was given. If I get a positive number, that interval exists above the y-axis. If I get a negative number, that interval exists below the y-axis, or the x-axis, sorry, wrong one. So let's practice plugging in. What number is to the left of negative 4 on a number line? Negative 5. Let's try plugging that into the original function. Or technically, you could plug it into this one too if you felt more comfortable doing that, because they're all exactly the same. Just one is more simplified than the other. All I'm caring about is if I get a positive number or a negative number. I don't care about what the number is. What are we coming up with? We're getting positive or negative? Negative. Then I pick a number between negative 4 and negative 2. What number is there that I could use? Negative 3. So when I plug negative 3 in, I'm going to save you guys the trouble because you can work through it on your own.
Let's go.
Okay, so between negative 4 and negative 2, I get a positive. Between negative 2 and 0, I get a negative. Between 0 and 2, I get a positive. Between 2 and 4, I get a negative. And between 4 and infinity, I get a positive. Which means when I go to graph this, I don't know exactly what the y values are going to be. I just know their general look. And I draw a rough graph. So between -4 and negative infinity, it was below the x-axis. Between -4 and -2, it was above the x-axis. And so on, I just keep drawing approximately what this looked like. This is an approximation. I have not the faintest idea if my y values are right, but I don't care. I don't, it's fun.
It's gotta get done.
I just care about a rough sketch.
Nope.
So here we have identified the intervals where my f of x were, above and where they were below. Questions, concerns, or issues with that one? Okay. Number 15, can I use, or 15A, sorry. Can I use synthetic division?
No,
Why not?
because facts.
Because I'm not dividing by a linear binomial.
It's divided.
So we just use our long division, which I guarantee you we need to practice. When I'm filling in or setting up a division problem with polynomials, what do I need to check for? In both the dividend and the divisor. I need to check in both. So when I set this up, I have 3x to the 5th. I don't have an x to the 4th, so I put a 0. Minus 4x cubed. I don't have an x squared, so I put a 0. And then all of that is divided by x cubed. I don't have an x squared, so I fill in a 0. And then I rewrite the rest of it. Move it down a little bit. So then I just go ahead and perform this long division problem. So when I do, I look at the first term of my divisor and the first term of my dividend. And I ask myself, how do I get from the divisor to the dividend?
3x squared.
I have to multiply by 3x squared. You can put it over here or up here, it really doesn't matter. So once I identify what I'm multiplying by, I take that and multiply it into each term in my divisor and write it under its corresponding term in my dividend. So 3x squared times x to the x cubed, oh my gosh, is 3x to the 5th. 3x squared times 0 is 0x to the 4th. 3x squared times negative 2x is negative 6x cubed. 3x squared times 7 is positive 21x squared. Put it in parentheses and subtract it from the terms above. 3 minus 3, 0 is out. 0 minus 0 is still just 0. Negative 4 minus a negative 6 is the same as negative 4 plus 6, which is positive 2. 0 minus 21 is negative 21x squared. And then I drop down my next term.
Hey, yeah.
Everyone okay with that?
Wait, I dropped them both down.
No, just one. And then I'll show you what we do next.
Shoot.
Okay. What do I notice about the next term in my divisor that I need to match? It's 0. So technically, we don't need to do that step. All I need to do is fill in the 0 that I would have had to multiply by.
You have
You have to put it, well, I would put a 0 in there as a fill-in. You don't technically have to because it holds no value. So once I recognize that, I don't have to do that subtraction step because I'm just going to be subtracting 0, which doesn't change anything. But we act like it did, so I go ahead and I drop the next term because now I can complete the next step. So then I ask myself, okay, how do I get from x cubed to 2x cubed? Multiply by 2. I multiply that into everything and I get 2x cubed minus 0x squared, or plus 0x squared, same thing, minus 4x plus 14 put it in parentheses, and subtract from the terms above. 2 minus 2 zeros. Negative 21 minus 0 is just negative 21. 1 minus a negative 4 is 1 plus 4, which makes 5. And then 5 minus 14 is negative 9. Am I finished or can I continue? Can I keep doing any more division?
No.
No, I'm out of terms in my dividend, and the remainder I got has a smaller degree than my divisor, which means I can't do it. Which means this entire thing is my remainder and has to be added to the quotient that I calculated using the division. So my final answer needs to be written as my quotient 3x squared plus 2 plus that entire remainder over my divisor. You do not have to leave the zeros in there if you do not want to. Yeah, sorry. And that would be my final answer. Questions, concerns, or issues with that one? Okay, so then 15b, can I use synthetic division on that one? Yes, because I'm dividing by x plus 2, which is linear, and it's a binomial, which means it has 2 terms. So when I do my synthetic division, I don't have to worry about filling in any missing terms, right?
No.
No, wrong. I have to fill in the zeros. We can't skip any terms, otherwise, if we do, I'll get the wrong answer. So when I fill it in, I have 6x to the 5th, 0x to the 4th, 0x cubed, negative 4x squared, 0x, and then 8. I know I'm dividing by x plus 2. So what do I do with that x plus 2 to find the number that I'm dividing from synthetic division? Set it equal to 0 and solve for x. So when I do, I get x equals negative 2. So that negative 2 goes in the top left corner. And then I complete my synthetic division process. Somebody talk me through the first step. Drop down the first coefficient 6. Awesome. Somebody else tell me what happens next. And my answer goes where, Becca? Which 0? The first one. So the next coefficient. Then I add straight down. And I repeat the process, right? Then negative 12 times negative 2 is positive 24. Add it down. Then I get negative 48. Add it down. Add it down. And I'm done. Is this how I leave my answer?
No.
No, we have to work backwards to identify my variable at each of these terms. So the last term is my what?
Remainder.
The term before that. And then the one before that, we just keep building my x's. So my final answer is 6x to the 4th minus 12x cubed plus 24x squared minus 52x plus 104 plus my remainder over my divisor of x plus 2. And then I'm done.
Is that it?
Well, that's all we're going to get to today, yes.
Okay, I have a question for you.
Okay, so anything else, I will get a video made going through the rest of them that you will be able to study with, and it will be on Canvas as soon as I can get it uploaded tonight.
How late? How early do you think that could possibly be?
Depends. I should get to it during my prep.